Hello everybody, my name is Walter and this is episode 66 of my Redstone Commands Series. In this episode I want to cover briefly how you can use scoreboard objectives to implement fixed point operations. So sometimes when you're working on a more complex data pack you need to actually do maths, and in many cases it's not enough to work with whole numbers, you actually need decimal numbers. Unfortunately, when you're working with scoreboard objectives, which are very commonly used for that, you have only signed integers available to you. They are from minus to plus around about 2 billion, which is a great span, but they are whole numbers. You can nevertheless emulate fixed point operations by using a scaling factor. So let's quickly talk about how that works. So the idea is pretty simple. Instead of just using an unscaled value, a, you use a scaled value, which is a tick, and that is basically just the value you want to encode, a, times a scalar. And that means that your resolution, which was earlier just 1 because you were working with whole numbers, is now 1 divided by the scalar. Very commonly you use scalars that are a power of 10, so 10, 100, 1000 and so on. You can, if you are going for a very specific resolution, also use something else, but those are the most commonly used scalars. Now, when you're working with values in the environment, you need to scale them before you can actually use them and then descale them once you're done with them. For that, you have primarily those two commands here. The first is data get with an optional scalar applied to the values you would get. And the second is the execute store command, which has a non-optional scaling factor again, which is applied before the values are stored away. And now it's time for a few examples for fixed point operations, because if you don't know what you're doing, you'll run into some issues. So let's quickly set up a few values. And we have two values, a and b, which are 10 and 3, scaled up with a scalar of 1000. Now let's start by adding b to a. And what we get is the expected 13. Always remember that 1000 is our scaling factor here. If we subtract b again, we're back to 10, as expected. If we do the 10 modulo 3, we get 1, as expected again. And similarly, you could do just copying, minimum, maximum, and swapping, and that would all work fine. Where we run into issues are multiplication and division. So I've reset to 10 and 3, and now I'm just going to do a simple multiplication of the two. And what we would expect would be 30, but what we get is 30,000, because we have one scaling factor too much in there. Similarly, let's reset and do the division. And instead of getting the expected 3.333, we get 0.003 and so on, because we're now one scaling factor short. So how can you resolve that? Well, we can do a scaled multiplication, which gives us the expected 30,000, and also a scaled division, which gives us the expected 3.333 and so on. Now let's have a quick look at how that is actually implemented in the code. So let's start with the scaled multiplication. So this is done in 3 steps. First, I'm just copying the value from a into s multiplication, so I'm not overwriting a itself. Then I'm multiplying with b. Now I have the scaling factor squared in there, so I need to divide by the scaling factor. The important part here to know is that you should first multiply and then divide, otherwise you're losing your scaling in the middle, and you would lose the additional resolution you won through the scaling. So if a would be something like 1.2, and you divide it by the scaling first, then you would get just 1 for the rest of the calculation, basically. So you would lose value information. So first multiplication, then division. Unless you're working with very big numbers, and the multiplication here would go beyond the plus or minus 2 billion a scoreboard objective can actually hold. Then you would usually have to first divide by the scalar and just live with the lost resolution. So, but usually first multiplication and then division. With that, let's have a quick look at the scaled division. Same idea as before. And again, first multiplication before division for the same reason as before. Again, just copying A. Then I'm multiplying, this time with the scalar. And then I'm dividing by B. So again, I'm first multiplying and then dividing. And with that, we've reached the end of this episode about emulated fixed point operations. I hope you enjoyed it. I wish you a nice day, and well, see you.